So we've successfully run our testing data through our model, and we have a bunch of predictions from it. But how accurate are they? Now it's time for us to score our model using different metrics. Don't forget that we have additional documentation linked on the screen and down in the description below. Now that we've successfully run our test, we can begin to compare the predictions to what the truth is. Remember that the data that we use to test our model, we actually do know what the forecast is. And so now we can do some basic statistics in order to determine how accurate our model was. The first thing we need to do is bring our output from our model, basically our predictions, into our Jupyter Notebook. So from the remote run, we're going to download the predictions file and read that in to a data frame called df_all. So now that our predictions are in our data frame df_all, we want to see how accurate our predictions are compared to the truth, or the actual count of bikes that were rented, or what's in target column name. To do this, we're going to use some common statistical methods for forecasting, namely the root mean squared error, the mean absolute error, and the mean absolute percentage error, which is the one that often is used with forecast systems. We want our mean absolute percentage error to be less than 10% for an excellent model, or meaning that our model is very accurate, and less than 20% for something that's good. We can see that the mean absolute percentage error is pretty high. What might help here is to visualize our predictions versus the truth. So this will create a scatter plot with the difference between the predicted column and the truth column in blue compared to the actual truth, which will be in green. We can see here that it's a bit off. The blue, the prediction, is a bit off from the truth. But does that mean that our model isn't actually accurate? Or perhaps does it mean that the mean actual percentage error isn't accurately representing our model? It's really important to choose the right tools, in this case, the right statistical methods, to make sure that the way that we're measuring our accuracy of our model is also accurate. So rather than just comparing our predictions with the truth, let's take a look at the metrics on our forecast horizon, meaning how well our model is performing based on future values, aka horizons, that we generated with our model. Remember, we were looking 14 days into the future. So now we're going to group our data frame by horizon origin and check out the same scores. Since we're in a time series forecasting scenario, it is better to calculate the metrics by forecast horizon. We can see that our numbers here are a lot lower. And again, we can visualize this on a plot. Here we're going to see the distributions of actual percentage error by horizon. On a log scale, the outlying absolute percentage error in the horizon 3 group is very clear. That means predicting 3 days into the future is probably not going to be very accurate. Setting our horizon at 14 days does yield a pretty accurate model. So I would say that our model is accurate enough if we're evaluating based on forecast horizon. So in that case, I think it's time to deploy our model.